Welcome back. Now the video is the third practical, which is on Tanner. Version I'm using is 15. 13 is same as that of 15. Again the same procedure: design, practical, third. Okay, adding the library files, devices, then miscellaneous, then spice commands, then spice elements. Okay, now I'll take cell, new view. Okay, transmission gate. You can refer the theory of transmission gate in the basic books or internet. I consider that you know the theory will go. So transmission gate is just a combination of PMOS and NMOS. We'll keep the PMOS instance and rotate it PMOS, and then you can take an NMOS, rotate it, done. Now these are connected, these are also connected. Next thing is I will be giving input here while taking an output here. This will be my control signal. For transmission gate to work properly, here the input should be proper. Rather, these both NMOS and PMOS, the NMOS and PMOS should be on for corruptionless transmission of the input to the output. So we can take here, we can connect an inverter and we can invert these signals. We can always give 1 here, we can always give 0 here, so that it will be always on. But to see if these are not given properly, what will happen, this we also need to see. That's why we'll give two different sources. First of all, we can keep bit sequence here so that I can visualize both what are the changes, what are the effects of the controls on the changes in the output. So let's go. Spice commands, voltage source. I will be needing the bit kind of source here, here and here. Done. Grounds in the miscellaneous thing. Okay, then by taking wire we can just connect these. Done. From here I need to get output. Let's keep Y. Here I can give input. Let's say it A. bit pattern I can change from here, 0 0 1 0 1 0, then here and here pattern should change. Now when you give 1 here, the NMOS will be on. Here 0 should come, then this should work. So I'll see first normal working, then we'll see 1 1 1, then we'll see corrupted working, then we'll see normal working. Okay, here exactly reverse of it, normal working, not normal, normal working. Taking the print voltages now, spice commands, print voltage, print voltage instance, and take these, then design is going here and there, so rather dancing we can take like this, done. Now these here we can put as inputs, just rotate by putting R. I can say here NMOS N input for convenience, P input for convenience. This is the thing, this is the transmission gate. This we can rotate it if it is creating some disturbances. These are connected already, so nothing is left. Go to setup simulation. Now here try and add library. If it doesn't work, we need to add that. Transient analysis, give 400 nanoseconds, 10 nanoseconds. This, if it doesn't detect, we can give that NMOS model. This is it. Let's see what we get at the output. Just run. Missing model definition of PMOSes and NMOSes. Again, the library files is creating a problem. Rather, the definition is not matching. That's why we'll give the input as the NMOS model text file to in the include desktop NMOS model. Okay, let's save and then run. Whether the transmission gate output we are able to get it or not into the waveform editor. Yes, it is there. Okay, split those. Okay, N input, this is the NMOS input. As soon as it goes 0, the PMOS input, as soon as it goes 1, the output gets corrupted here. Right. Now I can visualize it more clearly by increasing the pulse width. I forgot to do that here. Always try to keep it more so that I can visualize the changes whatever are happening there. Again, we'll see what happens. Whatever the errors you are going to get, you can trace it back into that T-spice. Now here it is clear, right? So here initially NMOS inputs are 1, PMOS inputs are 0. Whatever the input you are going to get here, A is my input, the same output is going to get repeated. But as soon as these control signals get changed, the NMOSes and PMOSes of the transmission gates are off and the output gets corrupted. Okay. Again, when it regains, the same input is going to get copied at the output. So this can be, this is actually enough to show how the transmission gate works. We can verify it using this STW editors. So thank you for watching, and please share any doubts if you have. See you in the next upcoming video, which will be a fourth practical, and it would be 2:1 marks using this same transmission gate. So yeah, thanks for watching.